Before we proceed to work on the materials for our assets, let's take a few minutes to organize our Katana recipe. I like to start by grouping areas of the Katana recipe that I tend to revisit the most by enclosing the relevant nodes in a backdrop. Select the Importomatic and Camera Create node, press Tab, and search for Backdrop. Press Enter. Selecting the relevant nodes before you create the backdrop will help save some time by automatically scaling to fit the node selection. Double-click on the backdrop and let's call this Assets, and press OK. I'll probably be editing the Gaffer 3 node frequently, so I'll create another backdrop around this node with the lighting label. Next, I'll place the Render Settings node along with the two PRMan nodes in a backdrop labeled Render Settings. And while the backdrop certainly makes our recipe nicer to look at, we now have the ability to move around between these backdrops by using the J hotkey. Press J, and as you can see, we have access to all the backdrops that we made. You can move between them by selecting the name of the backdrop. Now, let's work on the materials. While I won't be able to cover all the material setups in the scene, I've picked the treehouse assets for this lesson. But you can always refer to the Katana scripts that I've included with each lesson for the complete setup. I've grouped the textures that came with the asset into different folders. And based on this, we will need to create 3 different materials. But if you look at the asset itself, you can see that there are some parts of the asset, like the antenna here, that uses the same texture set, but it should have different material properties from the mostly wooden objects around it. Since the assets are using UDIM textures, most of them can share the same material. But in the next lesson, we will learn how to create overrides on specific objects when necessary, like in the case of the antenna. Let's start by creating a backdrop called Materials. While there are many ways to create a material in Katana, we'll only be using the Network Material Create node in this lesson, which is the most efficient way to create materials in Katana. Press Tab and type NMC. Select Network Material Create and press Enter. Set the edit flag on the Network Material Create node. I'll also rename this node to NMC_treehouse. Now let's take a look at its parameters. The first parameter we need to pay attention to is root location. This defines the location of the materials we will create with the Network Material Create node. I'll leave it at the default location. There is already a material created by default. We just have to rename this. I'll call this NM_TopHouseDeck. Now let's step inside the Network Material Create node by control middle clicking on the node or by clicking on the entry icon on the node. On the right side, you can see the output interface. And we have the RenderMan terminal open by default because I have RenderMan set as the default renderer. To create a shader, press Tab and type Pixar Surface. I'll call this node PS_TopHouseDeck. Now let's connect the output of this node to the PRMan BXDF input. All we have done until this point is to define a location called NM_TopHouseDeck that holds the Pixar surface shader that we just created. Katana has no information about which geometry this material should be assigned to until we explicitly provide this information. But before we do that, let's step out of the Network Material Create node and take a look at what's happening in the node graph. As you can see, the Network Material Create node lives isolated from the rest of the node graph. So we will need to merge this into our existing node graph before we are able to use any information it contains. And like before, we can use the merge node to do this. I made some room in the node graph for the merge node. And after merging the material, I've used a dot node to clean up the connection, which can be created by using the period key on the keyboard while hovering over any connecting line. While we are now ready to assign this material to the relevant geometries, instead of using a material assigned to directly assign our material to the geometry, I'll first create a collection of geometries related to the material group. I'll delete the collection create node we have made before. Press Tab and type Group Stack. The Group Stack is a special node in Katana that can be used to organize our node graph. While it can hold multiple nodes at the same time, it can only hold nodes of the same type. The Group Stack will help us avoid having to make a long list of collection create nodes, one after the other, keeping the node graph clean. I'll rename this Group Stack node and call it Collection Stack. I'll also create a backdrop called Collections. Set the edit flag on the Group Stack node, press Tab once again, and create a Collection Create node. Let's rename this collection to CC_TopHouseDeck. Shift middle click and drag this collection create into the Group Stack interface. We now have our collection create node inside this stack, and we also have a plus icon available to us now that we can click on to automatically add new collection create nodes. Now, let's take a look at the top house deck collection itself. Let's expand the scene graph hierarchy to the treehouse group location. I want to create all the collections under the relevant hierarchies. So for the top house deck, I want to create it under the treehouse group to make it easily accessible. Middle-click and drag the treehouse group location into the location parameter of the collection create node. In the name parameter, I'll call this cc_treehouse deck. If we set the view flag on the collection stack, you can see that the new collection has been added to the location we specified here. All we need to do at this point is to assign the relevant geometry locations to the treehouse deck collection. The top house deck texture set is made up of several different geometry locations. I'll expand the top house group to show all the child locations under it, and I will control-click on all geometry locations to select them at the same time. Click on Add Statements, append scene graph selection, and as you can see, the relative locations are automatically added to the collection. Now we are ready to assign the collection to the treehouse deck material. I'll once again make some room in the node graph for the material assignment. And once again, create a group stack node, which will become our material assigned stack. I'll call this material assigned stack. Create a backdrop and call this material assign. Set the edit flag on the material assigned stack and press tab and create a material assigned node. I'll call this MA_top house deck. Shift middle click and drag the material assigned node into the group stack interface. Expand the collections group in the scene graph and middle click and drag the top house deck location into the add statements widget on the material assigned node. All that's left to do here is to assign the material itself. Hover over the NMC_treehouse node and press Shift E to add the parameters of that node to the parameters tab. Middle click and drag the NM_top house deck into the material assigned parameter. This way, you don't have to manually change this assignment in case you change the name of the material, as it's now referenced by the material assigned parameter. Now we are ready to work on the shader itself. Let's launch a live render. I want to isolate just the top house deck geometry, but I want to do this in a non-destructive way. In the live render updates column, I'll shift left click on the assets, cam, light, materials, and integrators column in order for the live render to track changes to these locations. And in the render column, I'll add the specific geometries that I need to isolate all the top house deck geometry. We also need to enable rendering only the selected objects by clicking on the clapboard icon at the top of this column. And as you can see, it now renders black. This is because we also need to include the light location in the render column. Shift left click on the light location in the render column, and we can now see just the top house deck geometry we selected. This is called a working set, and they're not saved with the Katana session, but Katana has a bookmarks feature that you can use to save these and recover them at any time. Now let's start working on the shader itself. Step inside the Network Material Create node and expand the Diffuse tab on the Pixar surface node. To connect a texture, create a Pixar texture node from the tab menu. I'll rename this to T_diff_top house deck. We need to connect the result RGB into the color input on the Pixar surface node. You might have noticed that the output and input are both marked with green circles. This represents the data type of the output, and in this case, they're both of the color data type. To connect the result RGB into the color input, we just have to left-click on the green circle in this case, which picks up a connection line that can be used to connect to an input of the same data type. If necessary, you can also move around the material editor without dropping the connection line by middle-clicking the pan and using the mouse scroll wheel to zoom in and out. Let's now left-click on the color input on the Pixar surface node to connect them together. Next, set the edit flag on the texture node. In the file name parameter, let's browse to the diffuse texture for the top house deck asset. And as I mentioned before, the asset uses UDIM textures, so we need to replace the tile number in the file path with this specific syntax. We will just need to replace the number with capital UDIM enclosed in angle brackets. Now Katana will automatically pick the correct texture based on the UDIM tile information in the texture file name. Finally, I'll also enable linearize on this texture node as our texture is in the sRGB color space and we want to linearize any sRGB color data. Next, I'll connect the roughness texture to the primary specular roughness. So I'll once again create a Pixar texture node. Rename this to PT_top house deck _specular roughness. Load the roughness texture, and once again, change the UDIM tile number to the UDIM string replacement syntax. I don't have to linearize this texture as we are not using this texture for color data. Let's expand the primary specular tab in the Pixar surface node and look at the roughness parameter. As shown by the blue data type indicator, the roughness parameter expects a float input. So this will mean that in order to plug in the roughness texture, we either have to convert the result RGB output to float, or we can simply plug in any of the result R, G, or B channel into the roughness. I prefer to connect the R channel in all such cases to maintain consistency. Now, let's look at an example where we choose to convert the result RGB from color data type to float. Press Tab and type Pixar to float. Choose Pixar to float. Connect result RGB to the input on the Pixar to float node. Now that we have a float output, let's connect the result F into the roughness input on the Pixar surface node. Although such conversions are often necessary, in this case it only serves to make things a bit more complicated. So I'll hover over the connecting line from the Pixar float node going to the roughness input. As you can see, the line has turned yellow. Left-click on this and then left-click anywhere to disconnect the connection. Select the Pixar to float node and press Delete to remove this node. I'll once again connect the result R into the roughness input. Now let's look at the parameters of the primary specular lobe. Set the edit flag on the Pixar surface node and expand the primary specular tab. While there are valid workflows using the artistic specular Fresnel model, I'm going to use the physical Fresnel model on all materials in this course. Set the edge color to 0.95 on all channels. I'll leave the refraction index and extinction coefficient to its default values. But these parameters will become useful when working with materials with metallic properties, which we will look at soon. Next, I'll expand the advanced tab for the primary specular lobe and switch the specular mode from Beckman to GGX. It is correct to use either of these models, but the GGX model has a softer specular falloff, so you should use the model that works well for you visually. Next, I'll expand the specular and clear coat globals tab and set the specular energy compensation to 1. Now all that's left to do for the shader is to add the normal map texture. Press Tab and create a Pixar normal map. I'll rename this to N_tophouse deck. Set the edit flag on the normal map node. And in the file name parameter, load the normal map, and make sure to rename the UDIM tiles. Expand the bump orientation tab and set the orientation to OpenGL. You should note, however, that this parameter entirely depends on the application used to create the normal map, but in this case, it is OpenGL. Expand the globals tab on the Pixar surface node and connect the result N on the normal map node to the bump input on the Pixar surface node. That completes our first shader setup for now, but feel free to tweak the shader to your liking. We'll come back in the next lesson where we will look at setting up an interface for this material, create a new material within the same network material create node, and learn to use material overrides to change the material properties of a specific geometry. And finally, we will write all this information into a look file.